Hello, this is from Tushef. In this video, I'm going to show you how to use a CSV file exported from Massmotion to display the simulation here in Unreal using Atoms. So I have this scene with the environment exported from Massmotion that I imported here in Unreal. If you import the environment here, remember to set the location to 000 because the CSV contains the simulation workspace. Then drag and drop the CSV file, so you have the Massmotion cache here. And now let's create an agent group. Also for this agent group, remember to zero the location. And then we can attach Massmotion cache behavior. With the behavior, then you can point to the CSV cache, and then we need to set an agent type that we are going to use for the agents. Since we are using a lot of agents in this simulation, and you see the viewport is quite slow because all the agents are in LOD 0, we can select the agent group, go the first calling, and put the max screen area to 0. This way the agent will use the lower agent, the lower LOD, so it's better for your viewport. Okay, now let's add some animation. Need to add a state machine. And for the state machine, remember to set the state on agent creation only, because otherwise the state machine will continue to update the state instead of take the state from the Massmotion cache behavior. Now we need to tweak the ground for the ground adaptation. In this case, I have only one lever, so I could basically just translate the agent group. But if you have multiple levers, for example, a building, you need to set up an Atoms AI field. To do that, just need to go to the project settings, go to the collision, and create a new trace channel. In this case, I've created a new channel called ground. I set the block as the photo response, and then on the state machine, I can set that I field to ground. As you can see, some agents are not there on the ground because there is no ground there. In this case, I can just translate it a bit. Now it should be fine. So they are on the ground. And yeah, another things that probably you want to do is to disable the Footlock, because Massmotion is using their character. There could be a different proportion. They are not drawing the agent using input animation, but just pure simulation. So the Footlock system were not going to work well with this kind of simulation. So just disable the Footlock here. Let's go to the Massmotion, and then have to set up the two idle work state. In this case, my idle state is 0 and work state is 1. If you want to check where you need this value, you need to go on the state machine that your agent type is using and check the idle is 0 in this case and the work to 1. Then I need to set idle velocity threshold, so it means when the velocity go under this value, the agents change to the idle state, otherwise it's changed to the work state. So for example, in this case, let's try with a 0.5 value. Let's press play, let's see what happens. So here seems to work fine, but let's check here what is going on. So as you can see, there are basically agents that start work when they are basically is in idle position. This is because I have a transition clip on those agents. So let's go to the my state machine. On the idle work here, I have a transition clip. In this case, it's better to remove and use just linear blending. And the same thing for the other transition. Let me remove this one. Let me save. And now another things that we want to add basically is to make the transition happen as fast as it's possible, because otherwise Atoms will wait that one clip finish the loop. To do that, we can change the animation clips. So we can go on the idle and change the transition frames. So instead to have specific transition frame, you can put -1. But or another way is using a custom metadata. So we can add an metadata module, and let's call this metadata for clip transition, and let's put the value to true. And now let's press play. Let's see here. Yeah, seems that it's working better compared to the previous simulation. So now all the agents are basically following the simulation from Massmotion. Here probably we can fix the idle threshold. So let's go here, select the Massmotion cache behavior, and then let's put the idle velocity probably to 0.7. Let's try. Probably need to increase more. Yeah, now it seems a bit better. Anyway, you can try to find the right value for your simulation. Now if you want, we can add some variation on the color of the agents. So for example, we can create a metadata and call it color. It's vector. We can randomize this one. So select all value. Randomize. Okay, and then can go here and set that metadata as per instance metadata, so you can pass to the material. And now if we go to the agent material, so I have this texture, you can use the particle color, you can remove this one, and then I can connect. So this way I can remove those nodes here. And because the metadata is passed to the particle color nodes, so if I save, okay, it's done, and I have some random color agent. Obviously, you can randomize the agent type if you want. So you have all this kind of control that you usually have with Atom simulation. So that's it. Thank you for watching and see you in the next video.